Imagine a world in which a city-sized asteroid speeds through space on its way to a devastating collision with Earth. A crater 180 kilometers wide and 20 kilometers deep was left behind on the Yucatan Peninsula by the Chicxulub impactor, a cosmic giant that brought about the extinction of the dinosaurs 66 million years ago. Its destruction, however, did not end there. It caused our globe to go black for years by choking the skies with a suffocating blanket of dust and debris and causing tsunamis to loom over buildings. Imagine now if NASA is working in a race against time to divert a similar colossus that is speeding toward us. Will humanity be able to withstand another collision this size? Scientists everywhere are mobilizing their expertise and technology as you read this in anticipation of a possible end of the world. Are we really ready for the impossible? It's time to explore Space Lab. Welcome. Bruce Willis takes a group of astronauts into orbit to insert a nuclear weapon into a massive asteroid that is traveling toward Earth in the science fiction disaster film Armageddon, which was released in 1998. Their goal is to divide the asteroid in half so that it can pass safely over our planet's north and south poles. Even though this was a made-up asteroid strike, humans have previously experienced enough fatal asteroid strikes. The Tunguska event in 1908 was the first significant asteroid impact to strike Earth, causing an estimated 80 million trees across 2,150 square kilometers of woodland to be flattened. An asteroid almost the size of a tennis court struck Earth's atmosphere in 2013 at a speed of almost 70,000 kilometers per hour while traveling from southeast to northwest, causing another major impact. Approximately 1,500 individuals were injured by flying glass as a result of the hit, which broke windows throughout a metropolis. The energy released by the asteroid's explosion in the sky was equal to the detonation of around 500,000 metric tons of TNT. When determining an asteroid's impact, there are other factors to take into account besides its size. In the case of an asteroid impact, the kinetic energy that is delivered to the surface is converted into shock waves. There will be more tidal waves, explosions, and seismic activity as the damage increases with the asteroid's mass and speed. In addition to causing a crater, an asteroid's density and composition are important factors to take into account. The majority of asteroids have a stony composition, which increases the likelihood that they may explode before they reach the Earth's surface, according to research on fallen asteroids. While metallic pieces are fewer, they are dangerous because they can cause massive havoc when they reach the surface intact. The damage is contingent upon the size of the fragment. NASA scientists created the OSIRIS-RX mission to track and study these asteroids in order to address this issue. This was the first time a U.S. mission had visited Bennu, a near-Earth asteroid, to gather samples. Bennu is a potentially dangerous asteroid that is roughly 1/3 of a mile broad at its equator. It is an old artifact from the early history of our solar system, with over 4.5 billion years of history. The spacecraft landed on Bennu in 2018, and the sample was dropped on the Utah desert in 2023. NASA's Johnson Space Center in Houston's Astromaterials Curation team gathered 2.48 ounces of asteroid material from the sample hardware, more than they had anticipated, 2.12 ounces. To collect data for upcoming robotic and human missions, the team is now analyzing 25% of the material. In order to support impact mitigation missions, NASA will use this research to ascertain Bennu's physical and chemical characteristics. There is a good chance that Bennu will strike Earth in 2182, late in the 22nd century. The spacecraft has been dispatched to the asteroid 99942 Apophis to retrieve samples once the samples have been dropped. In 2029, Apophis, another near-Earth object, will travel less than 20,000 miles from Earth's surface and become visible to the unaided eye, bringing it dangerously close. With a 2.7% chance of striking Earth in April 2029, Apophis was dubbed the most dangerous asteroid when it was discovered in 2004. A deeper look, however, disproved this effect. Researchers noted that Apophis might go through a gravitational keyhole during its 2029 flyby, preparing for a collision in April 2036, precisely 7 years later. However, In 2021, this possible effect was also disregarded. Even though Apophis is not a direct threat, it emphasizes how crucial it is to be ready for such situations. The necessity of being alert and ready for cosmic dangers is underscored by the possible threat posed by asteroids. Although it left a permanent stamp on Earth's history by causing a mass extinction 66 million years ago, the Chicxulub impactor also served as a sobering reminder of the destructive force of big cosmic objects. We can now detect, track, and study asteroids more efficiently than ever before because to enormous advancements in modern science and technology. Finding near-Earth objects, NEOs, that might strike our planet is the focus of initiatives like NASA's Planetary Defense Coordination Office. The goal of this proactive strategy is to reduce the possibility that humanity may be caught off guard by an asteroid. The destructive potential of asteroids varies depending on their size, speed, and composition. Even smaller asteroids can do significant harm, albeit they may break up in Earth's atmosphere, as was the case with the 2013 Chelyabinsk incident. Bigger asteroids with the energy to change climates, cause tsunamis, and disturb ecosystems globally include the Chicxulub impactor and Bennu, which could pose a concern in the future. Scientists can create more precise models for forecasting the results of possible collisions by comprehending the mechanics of asteroid impacts, such as kinetic energy, shock waves, and crater formation. Designing successful mitigation methods, whether deflecting an asteroid or limiting its impact, requires this understanding. Technology for asteroid deflection is among the most promising fields of study. Humanity's capacity to change an asteroid's course is being tested by programs such as NASA's Double Asteroid Redirection Test, DART. The objective is to use kinetic impactors or other techniques, such as gravity tractors, to gently push potentially dangerous asteroids off their collision course with Earth. These methods necessitate accurate computations because, over time, even a small change in an asteroid's trajectory might provide radically different results. In order to increase our trust in our capacity to defend the world from potential asteroid threats, it is imperative that such technologies undergo successful testing. There is still a chance of an undiscovered or unreported asteroid, even if current observations indicate that there is no immediate threat from asteroids like Apophis or Bennu in the near future. Our planet's protection depends on ongoing investments in cutting-edge telescopes, space missions, and international cooperation. Studying asteroids offers important insights into the solar system's genesis and history in addition to planetary security. By comprehending these traces of early solar system events, we not only protect Earth but also deepen our comprehension of the cosmos, setting the stage for a time when people may use these celestial bodies' resources for exploration and survival. Even if there isn't a direct risk from any asteroids at the moment, it's best to be safe than sorry. Imagine a 20-story tall asteroid hurtling down at thousands of kilometers per hour. Its impact would be equivalent to thousands of nuclear bombs, causing unthinkable destruction. Hit the bell icon to keep updated, subscribe to Space Lab for the most recent space exploration discoveries, and leave your thoughts in the comments section below. Together, let's keep exploring.